Hi, Nancy.
Hi, Shane.
All right. Favorite space movie? Go.
Favorite space movie?
I know.
Spaceballs. Of course.
I was thinking about this. I took a much different track. I went much more serious. I was thinking Interstellar. Have you seen Interstellar?
Oh, yeah, I liked Interstellar.
I think I really just like Matthew McConaughey.
Well, who doesn't?
I know. Or more classic like Close Encounters.
Oh, we
Right?
just saw Close Encounters. It was like the 30th anniversary, and we saw it on the big screen in this
Ooh.
Dolby. Like you could feel the sound. It was so good.
Was it all digital, or did they do the whole like the old reels and all that jazz, or you just?
I really don't remember. I don't know, but it was awesome just seeing it on the big screen and like comparing it to like that one that came out recently where they talk to the aliens through music.
Oh, it doesn't matter.
Whatever.
Okay. Yeah.
Anyway, yes.
Cool. All right. Favorite planet?
Favorite planet? That's Earth.
Earth.
How about you?
Nice. I don't have one. I'm not. So this is my confession. I'm not a big space person.
I know.
Yeah. So, but hopefully we can maybe change my mind. Welcome to the American Geophysical Union's podcast about the scientists and the methods behind the science. These are the stories you won't read in the manuscript or hear in a lecture. I'm Shane Hanlon.
And I'm Nancy Bompey.
And this is Third Pod from the Sun. All right, so I'm not in love with space. So let's see if we can change my mind. And we're going to bring in one of our producers, Josh Speiser, to tell us a little bit about what he got for us. Josh?
Hey, Shane. Well, Lauren LaPuma, who is a regular producer on Third Pod from the Sun, who you'll probably know, she and I went to the NASA Goddard Space Center in Greenbelt, Maryland, which is just outside of Washington, D.C., to interview Jennifer Stern. Jennifer is a geochemist who is part of NASA's Mars exploration program to search for chemical signs of life on the red planet.
Great, so let's take a listen.
My background is actually earth science and environmental science. So I looked at fertilizer pollution in the Everglades and tracing that with chemistry. I also looked at methane in the Tallahassee landfill.
What would like your typical day be when you're going to a landfill in Tallahassee?
So there were these chambers that would sit on top of the landfill, and we would measure the methane that was sort of integrated in there coming out of them. Sometimes you needed to measure the methane that was coming out of basically where the trash meets the dirt. So you'd have to stick a long pole down there, long hollow pole, and then pull with a syringe, pull gas out of the top. And that was definitely the more stinky of the experiments. If you drive past them, sometimes they just look, they build houses on these things now. Like, they just look like hills, but really sort of bumpy sometimes. What's actually interesting is it's kind of pretty. It's like rolling green hills when you go to the more mature sections of the landfill. And there are these hills of compost where there are actually like mini watermelons growing. It's kind of weird.
So weird.
Florida.
Yeah, Florida. Exactly. It's Florida. But it's kind of funny because this whole idea of looking for methane on Mars, it's like we're looking for the same kind of thing. But what you're looking at there is biology. And so that's not so different than sort of the idea of trying to look for methane on Mars.
I mean, Florida can sometimes seem like another planet.
Especially when I go down to visit my mom during the winter and hang out with all of her and her friends, which is always fun.
So what kind of instruments does Jennifer design?
She designed a mass spectrometer, and that's part of the Curiosity Rover, which identifies the kinds of particles in the sample that are scooped up by the rover.
So how do you go about designing an instrument that's going to be used on Mars?
So that's definitely a tough one. And it never is just one person. So when I got here, this instrument was in full swing of being built and tested. And it was the first time that I had ever seen anything like it, because what I did was I worked with instruments in the lab. And so for me, going from how a lab instrument works to how you build something to go on another planet was really amazing. And the kind of way that the instrument has to perform is completely different. You care about completely different things. And so you work very closely with a whole staff of engineers and of instrument scientists and things that you don't have to worry about on Earth. So there's a lot of considerations that go into it. It all starts with sort of proof of concept in the lab. And a lot of times you take a bunch of parts and sort of cobble them together. So it's kind of messy at first. And then you develop something that maybe you can take into the field. You can take it into an environment that's Mars-like, whether it's because it's really cold or really dry, or maybe what you're looking for is very Mars-like.
What are those considerations for designing something to go on Mars or another planetary body versus Earth?
So the first thing you always start with is the measurement you want, and you look to see how it's done on Earth. And then you think, okay, well, I only have this much mass that I can put on the spacecraft. So I have a limitation in mass, and then there's limitations in the amount of power it can use. So you start stripping things down. Then other things you have to worry about is, is it going to be sitting on the surface on freezing surface of Mars? So you have to think about how is it going to be protected from that and what temperatures can it operate at? There are all these things that you don't really have to worry about on Earth that even when you reduce the thing to a small mass and a low power, you still have to worry about, can this thing function at extreme temperatures and with radiation and in just weird atmospheres. Like Venus is basically, there's sulfuric acid in the atmosphere. So you have to design something with materials that are going to be able to withstand that environment.
All right, Nancy. So what's the most extreme environment you've been in?
I would say July in the Louisiana bayou. It was so hot. I thought I was going to die.
I went to school in Memphis, Tennessee, and it was pretty absolutely terrible. But even if it's a bayou or Memphis, I bet Jennifer's instruments have to hold up in more extreme conditions than that.
Tell us how the instrument works, what it actually does, and how does it pick up samples on Mars, and what is it actually doing?
So the instrument measures volatiles, so it measures gases, which means an atmosphere measurement, it basically opens sort of a flap and ingests atmosphere. There are pumps in the body of the instrument, so it can remove the atmosphere and it can pump down and make a vacuum and then open a valve and let an atmosphere and measure the atmosphere. But for solid samples, it's a little more involved. And so for that, the arm of the rover has to either scoop or with a drill into rock and then take that sample, those drill tailings, and put them in the body of the rover where the instrument is. So once that powdered sample comes in, it goes into a little cup, and there's like 72 or 76 cups, and they're on a carousel. It goes into a carousel, that carousel turns and pushes the cup up into one of two ovens. And so the oven seals, and then you start to heat the sample. And as you heat the sample, that's when you make the gases. And the gases come off and go to the mass spectrometer. It's basically the size of like an old school microwave. Not like a nice newer one, but a kind of big old microwave, which is pretty big for spaceflight hardware. Mm-hmm. Lots of stuff is really small, but we've got pumps in there. We've got lots of, even the electronics, just everything takes up space. We take a sample maybe every few months because we're so power intensive. And we also take a lot of time. So if the rover's going and sort of the goal for that time is to actually move and get places, it's harder to stop and then do all of the work. You have to heat up the arm every time you use it. And then you have to get the sample. And so everything is the cost. It's a cost of time or it's a cost of power.
So once Jen and her team build these instruments, they don't just blast them into space on a rocket. They've got to road test them, find something here on Earth that's somewhat like Mars. And turns out that can be a bit of a challenge.
So first you design it in the lab, you take in all these considerations, and then you take it in the field.
We wrote a proposal to go to lakes in Greenland in the middle of winter. And the instrument is an underwater mass spectrometer. And it wasn't designed here. It was designed by folks who do underwater mass spectrometry, like in the Gulf of Mexico, to try to look for hydrocarbons and oil spills. But we want to work with them and try to design it in a different way so that it can look for the stuff that we care about as astrobiologists. So certain organic molecules, certain trace gases that are indicators of metabolism. And so they haven't ever used it in super cold and icy environments. So we're working with some folks who specifically design things like drills and melt probes for different planetary surfaces. So we're going to bring those folks together, try to do some testing in their lab. They have like a giant freezer where they can do some cold testing, and then bring this prototype that they sort of put together, bring it to Greenland in the middle of winter, and go to the site and hope everything works. And it's never just once. Each time you go into the field, you learn something that you forgot to bring something that you really needed, and then next time you can design it differently.
When you were telling me that, I'm kind of reminded of that scene in Apollo 13 when they throw everything on the table and they're like, make this out of this, using only this material. That's kind of what I'm imagining they're doing.
But yeah, it's like found objects. I mean, and there's just, you got the limited time, you're there, you got to figure out how to make it work. And usually you figure something out.
What's the craziest place you've had to go to for one of these field expeditions?
I did some field work actually in Mexico in these caves. They're these sulfidic caves where you have to go in and you have to wear a respirator, actually, because there's hydrogen sulfide, there's carbon monoxide, there's all these things that you can't breathe. And we went there, we were there during a flood. So to get to the place, it was an eco resort, but this was like an eco resort in winter, so nobody was there. And there was a raging river that they took us on this little tiny rowboat across. And I mean, they were fighting the current. And I was thinking, oh my God, I'm going to die. I mean, it was scary. Earlier that day, we were supposed to drive to a volcano, but because of the flooding, I mean, roads were just like, you drive on a road and then the road wouldn't be there. So it was a place where there's weird life. There's these sulfidic, they're actually called snotites, and they're like these sort of things that drip from the ceiling of the cave, looking like snot. And they're also some affectionately known clusters of organisms called phlegm balls as well. Nice. So it's all this stuff that's living in this completely, for us at least, toxic poison environment. But it's using the sulfur, it's using weird sources of nitrogen, it's using all of the things life needs. It's just not getting it from the place that we get it from, which is like, the atmosphere. And we were trying to, it's just one of the examples of trying to see how life is creative and can use different pathways to create what it needs. And to me, like, one of the whole reasons I do this at all is because I grew up watching National Geographic. And so for me, I was just like, even though it was a crazy trip and all sorts of weird, bad things happen, I was so excited because it was such an adventure.
And while Jen hasn't gotten to do any Mars-based field work, she has ventured to some pretty cool places, including Svalbard, try and say that, a Norwegian archipelago about midway between continental Norway and the North Pole, all in the name of science, team building, and of course, heavy metal.
What kind of fun remembrances?
Oh, yeah. So
crazy things that happen.
Right. In the Amaze project, which was the Svalbard project, there was everyone who was there for the first year, there was always a hazing type of event. And my first year, we were given a song by a Norwegian death metal group that we had to take and then rewrite lyrics and entertain the rest of the people who've been there more than 1 year. And we took this song and we put in a line about every one of the scientists, every one of the people who were there. And then this very small group, so this all took place at Ny-Ålesund, which is this sort of, it's a very small, it's almost a research town. It's not a real town, but I guess they have a fan club for this particular death metal band. So they had costumes for us. They had black boots and black vests and all sorts of metal stuff, and we put black makeup on our faces in the Kiss kind of style, and we went and we did our performance, and everybody was quite amused. So you go into the field to test, okay, does this thing I cobbled together, does it work to answer the question that I'm asking? Does it get the measurements that we need? And then the question of, okay, can it survive at crazy temperature swings is better done in a lab chamber where that stuff is tightly controlled. And then a whole big part of field expeditions is just like getting the people together who might actually be working together on a mission in the same room and, you know, working on the same stuff. And I definitely think that having done that in Svalbard with a number of the different teams that have instruments on Curiosity, like, it's so much easier to work with people when you've been out in the field with them because, you know, crazy stuff happens in the field. You stay up late, you work really hard, you drink beer, you know, it's a different than just being at the lab and coming and going every day. You're with people all the time, and, you know, you see all different sides of people. That's much more real than just sort of when you come to work every day.
Nancy, what different sides of me have you seen in our close working relationship?
Different sides of you? Sarcastic? More
No.
sarcastic?
No. Is it possible? All right. Well, so there's the people that she's working with, but I want to hear more about the rover. I want to hear about Curiosity.
When Curiosity was going to first employ those technologies, what was that like for you?
In 2012, in August, the mission, everybody went to Jet Propulsion Lab, which is where the mission was being run out of. And it's still run out of all of the sort of day-to-day operations of moving the rover and moving the arm and all that stuff. It's all centered at JPL. But everybody from all of the different instrument teams, so there's 10 instrument teams, everybody came there for the first 90 days to sort of be on the mission on Mars time, which is 24 hours and 40 minutes. So the days keep sort of getting later and later and later, and you keep having to shift your schedule and sleep at weird times and get up at weird times. So the first, you know, when we first landed, everyone was very excited, and then there's a lot of checking. There's a lot of checking if everything is still there, everything's fine, and then they start with sort of the most basic and simpler instruments and sort of do the imaging and the camera stuff. Well, we are the most power-hungry instrument, and we were the last to go. So we didn't actually get our first solid sample until after the first 90 days. So a bunch of us actually stayed extra because, you know, we wanted our exciting first time. And so we did get a first measurement of atmosphere, which was exciting. And the data came down at like 2 a.m. on a Saturday or something crazy like that. And we all gathered there and we had a bottle of champagne and, you know, it was very exciting and all the data came down. And when it comes down, everybody wanted to be the first person to see like that thing or to see that molecule. And people were kind of, you know, people sort of claiming their own molecules and that sort of thing. So there's a little bit of competition and a little bit of like, I want to be the first. But it was very exciting.
So I need to ask the question here that everyone has at this time, and it's kind of the elephant in the room. Is there life on Mars or anywhere in the solar system for that matter?
I tend to be kind of agnostic about whether life is on Mars or not. You know, I'm willing to entertain the evidence. I don't think we're going to find it on the surface. I feel like if we're going to find it, it's going to be on an ocean world. I feel like it's going to be in the oceans of Europa or Enceladus or even Titan, which is wild because there's not liquid water on Titan, there's liquid methane. But Mars is a tough place. And I'm certainly not ruling it out, but even if we go with drills, you're only going to that one place. And it's really tough with sort of the sample size of one to know whether you find it or not. And again, you know, the question of whether life is there is different than the question of will we find it? Because we are just limited in what we can do. But my bet would be one of the ocean worlds.
All right, so we're back to my hang up though about studying space. Why are we studying space when there's so much on Earth that we don't know?
If we think about human exploration, it's going to have some implications for advances in health science, big time, and medical science. But just the idea of something the whole human race can get behind, I think that's good. I don't think we have a lot of that. So I think space exploration, I think that's one big reason to do it. We have this incredible crew of people who figure out how to make the thing work and how to deliver the instrument. And then the instrument actually works the first time you use it. It's kind of a miracle.
Yeah. What is that feeling like? Just
It's exciting, and it gives me so much pride in the people that I work with who put this thing together, and makes me feel lucky because the instrument's working and I'm the privileged person who gets to look at the data. So we really depend a lot on all the people who actually put the pieces together. But it's trippy to see something that was built on Earth work on another planet, and to see data come back and that you're actually, hey, you're measuring something on Mars. It's bizarre.
So Shane, has this changed your feelings about space?
I mean, I'll probably never be a complete convert, but yes, I definitely see the value in space research, and this is some really cool stuff. So, a partial convert, as it were.
Yeah, it's so cool. And I think the thing that always gets me is a kind of that how space puts everything here in perspective, like the famous pale blue dot, Carl Sagan, and looking back at we're just a little speck in this big grand thing. It makes you think about your own humanity.
Well said, Nancy. And it was really cool to go and visit Jennifer at Goddard and to see the excitement she has for the work she's doing and what's coming up. I mean, this is real science. Then we're getting real data and learning more about our big red neighbor in the sky.
Awesome. So, all right, folks, that's all from us at Third Pod from the Sun. Thanks, Josh and Lauren, for bringing us this story, and, of course, to Jennifer for sharing her work with us.
And this podcast is also produced with help from Olivia Ambrosio and Caitlin Camacho. And, of course, thanks to Kayla Surrey for producing this episode.
We would love to hear your thoughts on our podcast. Please rate and review us on iTunes. Please. And you can always find new episodes on your favorite podcasting app or at thirdpodfromthesun.com.
That's it. Thanks all, and we'll see you next time.